Okay, so hello and welcome back. So the next thing that we have here is some basically some exercises related to these hyperbolas. And for example, suppose that you have this hyperbola over here, x squared over 16. You have x squared over 16 minus y squared over 9. Y squared over 9 is equal to 1, and you want to find the coordinates of the foci and the vertices and the eccentricity and the length of the lattice rectum of these hyperbolas, of this hyperbola over here. So we said that basically we had two forms of standard equations of hyperbolas, the ones that basically the forms that we did derive were basically x squared over a squared plus minus y squared over b squared. Y squared over b squared is equal to 1. Okay, so basically in this kind of exercise, if you have the value of the values of A, B, and C, you could essentially find out all of those pieces of information that you're looking for, meaning that the vertices, the foci, the eccentricity, and everything else that you're looking for. So the way that we can do that, of course, you can see that your A and B are already in here, meaning that if you compare these two equations together, you can see that basically A squared is equal to 16 and B squared is equal to 9. It means that A is equal to 4 and B is equal to 3. And there is a relationship between A, B, and C, which is the square, which is basically B is equal to B is equal to the square root of C squared minus A squared. And what that means is that basically B squared is equal to C squared minus A squared. And so since I'm looking for C here, C squared is equal to B squared plus A squared. So then I can write over here, I can write C squared is equal to 9 plus 16, which is equal to 25. So C squared is equal to 25, and so C is equal to 5. So now that we have the A, B and C, you can calculate, for example, the vertices of your foci. And we said that your foci are at a length C away from the center. But you also need to pay attention to the fact whether basically your hyperbola whether the transverse axis is across the horizontal axis or across the vertical axis. And we said that if your equation in this form, then that means that your transverse axis is across the horizontal axis. That means that, or basically your transverse axis is across the horizontal axis. Now, if your transverse axis is across the horizontal axis, that means that your foci and everything else, your foci and the two basically vertices are also across the horizontal axis. And so what that means is that since F1 and F2 are across the are on this, suppose that for example this is the horizontal axis, these two, basically these 2 points, let's say that they are your vertices, and these 2 points, suppose that these 2 points then for example are your foci. So then across this line, the y coordinate of every point is 0. That means that for example this point becomes negative c comma 0, negative c comma 0, this point becomes negative a comma 0, this point becomes a comma 0, and this point becomes c comma 0. And so now this is the situation where the transverse axis, this is the transverse axis is along the horizontal axis, along the x-axis in the coordinate plane. And when this happens, the standard equation of this hyperbola is going to be x squared by a squared minus y squared by b squared is equal to 1. And we learned another case as well, that basically we put the transverse axis, which the transverse axis that contains the foci and the vertices, we align that axis along the vertical axis, in which case you would get, for example, something like this. And then these would be your foci, for example, F1 and F2. The distances are not going to change, but of course the coordinates of these points are going to change, meaning that then on this vertical line, the x coordinate of every point is going to be 0. Meaning that, for example, then this point would be at a distance 0, a. This point would be will have the coordinates 0, negative a. This point will have the coordinates basically 0, negative c, and this point will have the coordinates 0, c. And when in this orientation, the equation of your hyperbola becomes x squared. You have to start with y squared. Becomes y squared by a squared minus x squared by b squared is equal to 1. So if you can remember these two cases, and for me personally, it's usually not possible to remember something in mathematics. I don't even remember my own phone number, and that's probably because I don't use it much. I don't give it to anyone. But usually I don't. I don't depend on memory much. It does not basically serve me in the way that they use that many people use their memory. For example, of course, I've been a student for a very short time. But most students, what they do, because they have a whole lot of things to read and remember, they just simply remember everything. Even when I was at school, I somehow managed to avoid doing that until I finally left school, and then basically I didn't have to do that anymore. Now, of course, I'm not encouraging in any way. I'm not encouraging this kind of behavior. your personal situation basically allows that, or if it's necessary for you to do that, of course you can do that. That's your personal decision. But when it comes to mathematics, I usually have to read a whole lot of things probably in a short amount of time, and of course I have to understand them and I have to learn them. Now the only way for me to do that is to really understand and learn how something really works, meaning that I have to basically derive all of the formulas on my own. All the formulas that I need to use, I have to derive them on my own. Otherwise, I will not be able to actually not be able to use them. That's my personal experience. When I just simply copy a formula from some book or somewhere, I will not be able to use it to find out other values in that formula. It's not possible for me, and the reason for that is that I don't simply understand the formula. But when you derive a formula, or when you derive an equation, first of all you have to understand that situation. So when you understand the situation, of course you know what you can do and what you cannot do in that particular situation, what you're allowed to do and what you're not allowed to do in that particular situation. And then based on that situation, based on the constraints imposed upon that situation, you will come up with a formula. And then of course it's very easy to decide what you can do with this formula, what you cannot do with this formula, and so on and so forth. So for example, in this equation, I know that A and B, these are distances. So of course a distance cannot be a negative value. I cannot just go on and for example find a negative value for A and put it in this formula. That it's not going to work. And of course in calculation, if I come up with, I don't know what's going on over here. In calculation, if I go on and find, for example, some negative value or some unreal value for A or B, of course I know that value I'm not allowed to use it in this situation, because it's just simply a distance and it has to be a real number, a positive real number. So that's basically how I do things. Now, long story short, if you can remember these two situations, you will be able to basically write down the coordinates of your foci and your vertices over here. Now over here we said that you have x squared by a squared, y squared by b squared. So it's basically this situation over here. All of your points are along the horizontal axis, and that is basically the whole situation going on over here. So now I'm going to erase all of these things and come back over here. And so now basically I know that in order to find the coordinates of for example my vertices, let's say that V1, we said that basically the points are going to be along a horizontal line. That means that the y coordinate over there is 0. So the vertices are at the distance a from the center. So it's going to be basically plus or minus a, meaning that 4, 0, and then V2 would be negative 4, 0. Your foci would be at the distance f from the origin or from the center at the distance c. So that would be 5, 0, and f2 would be, for example, negative 5, 0. Then you have the other thing that we were looking for was the eccentricity, and we said that the eccentricity E was the ratio of C to A, which is equal to basically 5 to 4, 5/4 over here. We were also looking for the length of the lattice rectum, which was equal to 2b squared by A. So 2b squared by A is equal to 2 times 9 is equal to 18. So 2 times 9 divided by 4, which is 9/2. And that's basically all the information that you need over here. So let me check my answers here to see. What is the 11.4. Okay, the answer is right. Okay, so now suppose that you have, for example, some hyperbola with the equation y squared by 9 minus x squared by 27 is equal to 1. So you can see that over here the positive term is the or the negative term is the term that contains the x squared. And what that means is that you have your basically your foci and the vertices and everything along the vertical axis, meaning that it's basically some situation like this. So now, since this is the case, then your vertices and foci and everything are going to be along this line, meaning that over here the x coordinate of every point is 0. You need to remember that. So the x coordinate of every point by every point, what I mean is that is basically v1, v2, f1 and f2. That's what I mean by every point is 0. So of course it is actually a good idea, because we usually have this habit of talking about things in an uncareless way, or I don't even know if that's a word, but we don't really care about whether basically what we say is true or not. When I say the x coordinate of every point is 0, I have to specify what I mean by every point. So what I mean is, for example, the x coordinate of v1, v2, f1, f2 is 0. And now this is this is a mathematically acceptable statement which has no ambiguity. That's important about such statements, meaning that it's actually not a good idea to basically to use words loosely, because you will end up harming yourself and you will end up harming everyone else around you. That's the problem with that. So basically what you want to do is that, since you know the equation, the orientation of your hyperbola is this way, you know that your equation is basically y squared by a squared minus x squared by b squared is equal to 1. Is equal to 1. So now if I compare this equation to this equation, I can easily see that a squared is equal to 9 and b squared is equal to 27. That means that a is equal to 3 and b is equal to the square root of 27. The square root of 27. Now the only thing that I need to calculate here to get these points and other information that I need is c. So again we said that c is equal to the square root of b squared minus a squared. I'm sorry, b is equal, that's what I was talking about. I can't really remember such things. B is equal to the square root of c squared minus a squared. B is equal to the square root of c squared minus a squared. C squared minus a squared. So if that's the case, so you see the problem with this kind of thing, if you know enough about your own mind, you know that when basically the process of learning, if you want to learn something properly long term, and if you want to learn it in such a way that you can use it actually in some meaningful way, it has to be based on the way that your mind works. Now human mind, or at least my mind, works based on this basically it works basically this way. For example, let's say that, let me give you an example. I want to give you this example so you can understand how you can effectively learn. You see, if there is a concept, for example, suppose that there is a concept called a hyperbola. There is a concept called the hyperbola. Now, related to this concept, there is basically all the definitions. There is all the definitions, there is the equation, there is for example, in the context of what we are doing here, there is the lattice rectum, and that's basically all that basically we do over here. We do, for example, we have done about hyperbola over here. So in a very, if you want to learn this effectively, what you can do is that, the concept is hyperbola. So I can simply start with a simple diagram and simply define something for myself as a hyperbola, and related to that definition and to that diagram, I can have some definitions so that everybody can understand. There is no problem with that. So the definitions are taken care of, and those definitions are based on that diagram. and a diagram is something graphical that you can very easily understand. Then based on that diagram, you can derive the equation, and of course when you derive the equation, you will understand, since you have understood the situation over here, the situation of the diagram and everything else, and all the lines and geometry and everything, then you will understand the equation. And then, for example, there is the lattice rectum, for example, then you can do that in the same way. And then my mind can hold this whole thing together as a concept. My mind can hold this whole thing together as a concept, and everything related to this concept, as long as they are all logically related facts, I can basically keep them indefinitely. And of course, since it's a concept, it's a basically network of facts, basically all logically linked together. If there is any link there, for example, suppose that there is all of these links over here put together in different ways. For example, this way, this way, this way, and then these two are linked together, and then these two are linked together, and so on and so forth. So in your mind, this becomes a concept. Meaning that, let me do this more properly. Related to this concept, there are all of these definitions. For example, there is a fact here, there is a fact here, there is a fact here, and so on and so forth. And then this is linked to this. For example, this is linked to this, this is linked to this, this is linked to this. For example, this is linked to this, this is linked to this, and so on and so forth. And once you have understood the whole concept over here, if it often happens that, for example, you will lose one of these links. Suppose that you use, for example, this link over here. If you lose it, there is always some way for you to basically go back, for example, along this path and go back over here and figure out what this link was, and then you will always be able to figure it out. But suppose that you give me some formula. Of course, this is not a good example over here, because there is actually some relationship between C and A and B, and I haven't taken the time to understand that. That's why I can't remember it. But suppose that you just give me some formula like that, and I don't know, and I'm just supposed to basically memorize this. Now this thing over here is very, very loosely somehow connected to the concept of hyperbolas that I have in my mind. But it's not really connected to anything. So I can lose it at any time. And when I lose it, there is no way for me to go back there and see what it was. There is no link there. It's basically like the beginning of time. In the beginning of time, there was nothing, if we can assume that. In the beginning of time, there was nothing, so you cannot link anything to there. So that's the problem with this kind of thing. So if you want to learn effectively, of course, this is not a model that works for our current educational system. Our current educational system is mainly based on competition and basically being fast and being effective in of course in a completely different way, and being and of course performing better than others and things like that. So this model is not going to work for the current for our current educational system, but this model is actually based on how the human mind works. That means that our current educational system is actually not based on how the human mind works. And that's why we have, that's one of, you could say that's one of the reasons why we have so many problems around us in the world. So, but if you, for whatever reason, if you want to learn basically effectively, and that you have to do with your mind. You have no other tool to do that. You have to first find out how your mind works, and then use it in the same way that it works, because you cannot change the way that your mind works. It's not possible, really, because it's like physics. You can understand the law of, for example, the force of gravitation or the law of gravitation, but you cannot change it. Human mind is exactly something like that. You can understand how the human mind works. You cannot change the way it works. And once you've understood how it works, then you can very simply use it in the exact same way that it works, and it will work for you. It's a very, very, very scientific process. Okay, so now enough of philosophy. Now let's go back over here and actually solve this problem. Okay, so now I have basically my A, I have my B, and I want to figure out what C is. So C over here I can calculate it. So if I can write B squared is equal to C squared minus A squared. So that means that C squared is equal to A squared plus B squared. So C squared is equal to 9 plus 27. 9 plus 27, which is equal to 36. So C squared is equal to 36. So that means that C is equal to 6. Now, over here we said that basically the points over here are along this vertical axis. That means that the x-coordinate of every point is 0. So the vertices, for example, V1 would be basically the x-coordinate is 0, so 0, comma A, and then V2 would be, for example, 0, comma negative A, which would be, for example, 0, 0, comma 3, and 0, comma negative 3. Then the foci would be, for example, F1, 0, comma C, and F2 would be 0, comma negative C. So that is 6. So that's 0, comma 6 and 0, comma negative 6. And then the length of the lattice rectum is equal to 2 times B squared divided by A, which is equal to 2 times 27 divided by 3. This is equal to 9, which is equal to 18 units. And then you have eccentricity. Eccentricity is equal to C divided by A, which is equal to 6 divided by 3, which is equal to 2. And then you have, basically that's all the information that we need here. So number 2, plus or minus 0 plus or minus 6, 0 plus or minus 3, and then E is equal to 2. E is equal to 2, and then the lattice rectum is 18 units. Okay, so number 3. So now suppose that you have some hyperbola in this form. For example, let's say you have 9y squared minus 4x squared is equal to 36. So if that is the case, since I want to get my equation either in the form x squared by a squared minus y squared by b squared is equal to 1. So you have a 1 over here. Or it has to look like something like this, meaning that you have to write it as basically y squared by a squared minus x squared by b squared is equal to 1. Again, you have a 1 over here. So you want to have a 1 over here. So what you want to do is basically divide by 36. So now 9y squared divided by 36 minus 4x squared divided by 36 is equal to 36 divided by 36. So this is a 4 over here, this is a 9 over here, and this is a 1. So that means that y squared by 4 minus x squared by 9 is equal to 1. So now that you have written your equation in this form, which is essentially this form over here, since basically the positive term is the term containing y squared, then what that means is that basically your points are across the vertical axis. Your points are all across this axis over here. This axis over here. Across or along this axis over here. Now, so if I compare these two equations together, I get basically a squared is equal to 4 and b squared is equal to 9. That means that a is equal to 2 and b is equal to 3. Now again, the equation that we had was about to find c was basically b is equal to the square root of I really have to write down this formula somewhere and keep going back to it. Hyperbola. So we said that b was equal to the square root of c squared minus a squared. C squared minus a squared. So that means that b squared is equal to c squared minus a squared, or c squared is equal to basically a squared plus b squared. So now c squared is equal to basically 4 plus 9, which is equal to 13. So c squared is equal to 13, and so c is equal to the square root of 13. C is equal to the square root of 13. And so the points that you have over here, the vertices are basically at this, along this vertical line. The x coordinates are 0, so 0 comma a. v2 would be 0 comma negative a. v2 would be 0 comma negative a. And so basically v1 would be, for example, 0 comma a, which is equal to 2, and so this point becomes 0 comma negative 2. Then you have, then basically your foci are at f1 are at 0 comma c, and f2 would be basically 0 comma negative c. So this would be basically 0 comma square root of 13. And there is another question over here. I basically, if you, especially in this video, if you experience any sort of disarrangement of the video, I have been going back and forth, especially in this video. and if anything is wrong with the order of the exercises, or if the video probably jumps to some other place where you don't understand or something like that, I apologize for that, but I hope that it's not going to happen in the other videos, because this video, for whatever reason, it just I just had to go back and forth, stop, start, pause, and so on and so forth. So all of those things might actually have happened, and if that's the case, I apologize for that. Now, question number 5 is 5y squared minus 9x squared is equal to 36. So if I want to get a 1 over here, I divide by 36. So 5y squared divided by 36 minus 9x squared divided by 36 is equal to 1. Now I can write this as basically 5 divided by 36 times y squared. I can write it as y squared divided by the reciprocal of this. Y squared divided by 36/5. And that's what I'm going to do here. So I write this as y squared divided by 36/5 minus 9 times, so 9, and basically that's a 4 over here, minus x squared over 4 is equal to 1. So now basically if I write this equation as y squared over a squared minus x squared over b squared is equal to 1, then a squared is equal to 36 by 5, which means that a is equal to the square root of 36 is 6 over the square root of 5. And I suppose b becomes basically, so over here b squared is equal to 4. B squared is equal to 4, so b is equal to 2. B is equal to 2. Now if I assume that b is equal to, or basically b is equal to the square root of c squared minus a squared, c squared minus a squared, then that means that basically what that means that is b squared is equal to c squared minus a squared, and so basically I have here ab, and so c squared is equal to a squared plus b squared. So c squared is equal to 36/5 plus 4, which is equal to basically 5. 36 plus 20, which is equal to 56/5. So c is equal to the square root of 56 by 5. I suppose there is something wrong here, because now let me calculate everything based on this, and then we will see what happens. So now basically the foci, and based on this I know that basically the foci are along the foci and vertices are along the y-axis. So if that's the case, then for example f1 is going to be equal to, along the y-axis, your x is equal to 0, and that would be a. For example, f2 would be 0 comma negative a. c1, and basically the vertex 1, v1 would be basically 0 comma, actually this is supposed to be c, and this is negative c, and this is a, and v2 is supposed to be negative a. So that means that f1 is supposed to be 0 comma c, which is 0 comma the square root of 56 fifths, and your f2 is going to be at 0 comma negative square root of 56 fifths, and your v1 is going to be at 0 comma a, which is basically a is equal to 6 over square root of 5. So 0 comma 6 over square root of 5, and v2 is equal to, is the same as 0 comma negative 6 over square root of 5. And then your basically your eccentricity, which is equal to c divided by a, that's supposed to be basically square root of 56 fifths, over a, which is equal to 6 over square root of 5, over 6 over square root of 5. Now you can write this as, square root of 56 over square root of 5 times the reciprocal of this, which is square root of 5 over 6, and then you can cancel these two out, and that becomes a square root of 56 sixths. That is your eccentricity. And then the length of the lattice rectum is equal to 2 times b squared over a, is equal to 2 times, so b squared over here is equal to 4, so 2 times 4 over a, which is equal to 6 over square root of 5. 6 over square root of 5. So I can write this as 2 times 4 times the reciprocal of this, which is square root of 5 over 6, divide by 2 3, divide by 2 1, so that is 4/3 square root of 5. Now these answers most probably will not basically agree with what we have in the book as the right answers. For example, the length of the lattice rectum over here I've got at 4/3 square root of 5, which is not wrong. The eccentricity I've got at square root of 56 sixths. Let me write this as, let me see what the problem is. Maybe the numbers are in different forms. So for example, the eccentricity over here, number 5, square root of 14/3 square root of 56 sixths. like I have square root of 56 6 square root of 14/3, which is the same number. And I have a couple more numbers. For example, my a as I've gotten a 6 over square root of 5, and so 6 over square root of 5, and 6 is square root of 5/5. And 6 over square root of 5, and over here I have 2 square root of 14, 2 square root of 14 divided by square root of 5, square root of 5. Not the same thing. I don't know what the problem here is. I don't understand it really. Maybe the answer in the book is wrong. We can actually test this. We can actually test the answers that we've gotten over here. I can graph this equation, meaning that you can always go to, for example, let's see if Desmos does this kind of thing. So for example, if you go to desmos.com and enter this equation, 5y squared minus 9x squared is equal to 36. And you get this, basically you get this hyperbola over here. And as you can see, these are the coordinates of your foci, for example. And well, the vertices are not there. This doesn't show your vertices. But for example, the foci over here are at 0,2.683. And if basically the foci that I got over here were, the vertices that I got over here was 6 over square root of 5. 6 over square root of 5, 2.683, which agrees with the graph over here. And the answer that we have in the book does not really agree with the coordinates of the vertices, at least over here. So there is something wrong with that answer. Anyway, that is basically one way that you can verify whether your answer is right or wrong. Draw the graph of the function, or not the function but the hyperbola, or have it drawn using some sort of software, for example desmos.com. There is other graphing calculators as well online. You can use them all, and that way you can get your job done. So I'm finally done with the first hour of my video. It took me quite some time to get through here. We have a couple more questions to go, so I'll see you in the next video.